Here, and this is structure and function of the muscular, nervous, and skeletal systems within the body. This presentation is presentation 1 of 9, and I will be talking muscular system, gross anatomy, and skeletal muscle throughout this throughout these series of lectures. Okay, so let's get going here. Within chapter 1, these are the main things that we're looking at. After completing this chapter, you'll be able to do these things: describe structure and function of skeletal muscles, etc., etc., etc. And this will be over the course of our 9 presentations. With that, we have 3 main types of muscle in the human body. We have smooth, which is non-striated. It doesn't have a striation in it where the muscle fibers connect and have cross-bridge attachments. And usually you find this in the walls of the internal organs and blood vessels. And these are the types of muscles that are used in peristalsis to help us in digestion, to move food, and as part of the digestive tract. And you have cardiac, which is very specialized. It's involuntary, and when you look at the contractile mechanism for this, it's a little bit different in terms of how it contracts and where the actual contractile impulse comes from. I'm not going to get too deep into that. But when you start talking about cardiac muscle itself, it's the fibers that work in conjunction with one another and in proximity to each other as they contract to wring the blood out of the heart and push it to the rest of the body. What we'll be focusing on, for this course, if I can get myself out of the way here, it will be exclusively, majority of it will be skeletal muscle. It's voluntary, it's striated, attaches to bones via tendons, and it helps us create movement. And with the human body, we have these kind of gross motor muscle groups that we talk about a lot in the gym, right? We always say, I'm going to work delts today, or I'm going to work pecs today, or legs. But you have different subcategories within each muscle group. But big picture, you're thinking large muscle groups first. And with the muscle itself, you have movement that's created that's both gross motor, but also fine motor. Writing with a pen is a lot different than leg pressing 500 pounds. And the muscle required to do that and the amount of muscle required to do that is different between one and the other. So to the right, what you see are like the main gross motor muscle groups, everything from delts all the way down to tibialis anterior, and the anterior view, which is over here to the left, which is the front of the body, posterior view, which is the back side of the body, everything from trapezius all the way down to soleus. So I would take a moment to acquaint myself with these because you'll find them later on in the class. So the epimysium. The epimysium itself, there's connective tissue that connects the deltoid to the deltoid tuberosity on the side of the arm. But the connective tissue that you have that is a tendon type material, there's also tendinous-like material that actually goes through the muscle groups and helps kind of hold everything together. I just want to take a quick moment in terms of having an anatomy sidebar here. You have different prefixes. You have epi, peri, and endo. And these are used to describe different layers, epi, peri, and endo. And with muscle, you have the epimysium, the outermost layer, the perimysium, which is kind of the middle layer, and the endomysium, which is the innermost layer. Mysium, M-Y-S-I-U-M, is muscle. I believe that's Greek, if I remember correctly. So the way maybe you can remember this is epimysium is the outermost layer, and if you've ever been acquainted with, practiced, or had to actually help somebody use an EpiPen, you have an EpiPen is used to inject epinephrine into their thigh to save their life if they're having like an anaphylactic situation. So epi in this context can be almost like a double entendre, right? Where you have the abbreviation for epinephrine, but also the needle must go through the outermost layer of skin of the body, which is the epidermis. Dermis is terminology for skin. So think of this in terms of EpiPen is going through the epimysium, the outermost layer. And once you have that, epi's one, endo's the other, and then you have a perimysium in the middle, EPE, right? So that's how you're going to remember that to get through all the quiz questions and test questions. All right, so we'll go back to the epi, peri, and endo. Epimysium is the outermost layer that's up here denoted with this circle. It's kind of a dark, if you will, black color. And that's the outermost color up here in the muscle belly. Then we go paramecium. The paramecium is what kind of holds these smaller subsections all together. And then we go with the endomysium. The endomysium is what holds within each one of those kind of mid-range sections, holds all those smaller ones together. Another way to look at this, and I found this cross-section picture of a cable, of a bridge cable. And when you look at the bridge cable itself, it's pretty striking in terms of you have this kind of outermost layer, and the outermost layer that you have is almost analogous to like the epimysium that we see in the muscle. And then you have this kind of inner layer, and there's different bundles. You can see one here, another one here, another one here. They kind of go around the outside. That's your paramecium when you look at like a bridge cable, for God's sakes. And then we go with an endomysium. That's the individual cables themselves within the overall bridge cable. I just thought it was an interesting comparison to have. Maybe it helps you kind of visualize it a little bit better. So when we look at this in terms of side by side, you have the muscle group, the fasciculus. So let me go back there. The fasciculus itself are the muscle fibers. You can see that here. And the fasciculus are the muscle fibers, and you have the individual muscle fiber itself. So you have, from big picture, epimysium, outer layer, paramecium, P is the middle layer, endomysium is the innermost or deepest layer. So from the book, I would definitely take a moment to kind of review this passage and maybe even rewrite it a couple times just so you remember it and commit it to memory. Muscle makes the movement happen, but it's the connective tissue that transfers the forces from the muscle fiber to the bone. That's the lever. And the connective tissues that we have that we talked about are the epiperi and endomysium. They both connect, but they also separate muscle itself. So, take a moment just to kind of read through this and make sure you've kind of committed it to memory, because you're going to see it somewhere later on. All right, I'm going to move on to the next presentation.